Right, so welcome. So what exactly is the standard unit vector? Well, to do that, I want to kind of talk about, just a vector in general, all right? And when we talked about vectors in general, let's just say you have an initial point and a terminal point, right? And we'd say, let's call that vector v, and that vector is at v1 comma v2. All right? Now, the important thing about this, here's a vector in component form. And when we're talking about a vector in component form, one of the things that we learned how to do was to find the unit vector. And what the unit vector was, a vector that was in the same direction, but only had a magnitude of 1. So to kind of understand the standard unit vector, we need to kind of enlarge this unit circle and kind of talk about the standard unit. So what I'm going to do is I'm going to create a nice little unit circle. It's not so bad. All right. So remember on the unit circle, our distance of our unit circle is 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Right? Those are points that are on the unit circle. Well, all the standard unit is exactly these two vectors. The first vector, which is on the x-axis. All right. Now we know since it's on the x-axis and it ends at the unit circle, we know that it has a magnitude of 1, right? So this magnitude, this vector, we'll call this directed 1 comma 0. Because again, we're not talking about the point. We're talking about the vector from 0 to the end of the unit circle on the x-axis. And we call this I. Okay? It's not the I with the little squiggy. That was our imaginary numbers I. It's just a lowercase bold-faced I. Now, the other standard unit vector is going to be on the y-axis. And again, that's representing the vector that's going from 0 to 1 on the y-axis. And we give that vector a directed line segment of 0 comma 1. And that vector we call j. All right? So if we look at a vector, sometimes we write the vector in our component form, right? We say v is equal to v1 comma v2. But if we kind of think of these, so if we were going to look at this, rather than looking at this unit vector, well, actually let's just do it in a different color. So let's look at what I and j would be. Here's I, right? And there's j. Now that's a negative j, obviously, but it's j going out in the negative direction. So there's your I, and there's your j. So one thing we also want to do is write our vectors not only in just component form, but also sometimes we like to write it in our standard unit form. So what I can do is, here's my point, right? So how many i's do I have to get over to this point? Well, the number of i's at this point is going to be v1 I, right? Because it takes v1 times to get over here. 1, 2, right? It's going to take v number of unit vectors to get to this point. So we'll say v1i plus how many unit vectors is it going to take for us to get down here? And that's going to be v2j. So we can represent v not only in component form, but we can write it as a linear combination of the standard units I and j, where it's just v1i plus v2j coming from our component form. And that is going to be what your standard unit vector are going to be. Thanks. Now, it might make a little more sense, so let's do